noticed during or after I finished recording my last recording that the recorder stopped partway through this problem. So I'm going to try and jump in where I left off and finish up this presentation. Sorry that it's 3 videos instead of just 2, but here we go. So we're moving back to this picture. We have this equation. We wanted to know when will this arrow being fired off a building cross the 288-foot mark, not when it hit the ground. So we're not setting it equal to 0. We want to set this equal to 288 and see where it crosses that 288-foot mark. And so I think that's where I left off in the last video. So now we're going to solve. So that's the big general picture of what's going on, what we're trying to do. Now we need to do the kind of the nitty-gritty, the arithmetic here, and figure out the solution. So we can't use the zero product property as it sits right now because it doesn't equal 0. So we need to make this equal 0. I'm going to choose to move everything to the right, or to the left side of the equal sign. So move everything to the left side of the equal sign, just because that's the way we're used to seeing it. It doesn't really matter, but I'm gonna move it to the left side. So I'm going to add 16t squared to both sides of the equal sign. I'm going to subtract 112t from both sides of the equal sign. And I'm going to subtract 128 from both sides of the equal sign. And because I've done this twice now, I know that that's 160. Otherwise, I'd probably use a calculator. Equals 0. Now, at this point, I could use the AC method, and I could try and factor this as it sits. However, I think an easier way is to try and find a common factor between these 3. And so 16 looks like it might work. I know that 16 is a factor of the first coefficient and of the constant here. And so I'm going to grab a calculator, and I'm going to double check that I can take 112 and divide it by 16. And I can. If I couldn't do 112 divided by 16 evenly, if 16 was not a factor of 112, I would try 8, I would try 2, I'd try 4, I'd try something to try and simplify this quadratic down. So I can factor a 16 out of all of those pieces, all of those terms. I get t squared minus 7t plus 10 equals 0. And then because this is multiplication, there's nothing stopping me from dividing both sides by 16. Or multiplying by 1/16. 16 divided by 16 is 1. So I have 1t squared minus 7t plus 10 left over. And 0 divided by 16 is 0. So that, again, cleared up a lot of those larger numbers. I have much smaller numbers to work with. And I am going to try and factor this. So I need, there's no coefficient here for 1, or leading coefficient. So it's like a 1. So I'm going to find 2 numbers that multiply to 10 that also add to -7. Well, -5 times -2 equals 10, and -5 plus -2 equals -7. So my factors are going to be t minus 2 and t minus 5 equals 0. But again, the solution set is not -2 and -5, because that would mean that the arrow crosses that 288-foot threshold at -2 seconds and -5 seconds. And that just doesn't make sense in our way of thinking about time. So the solution would be, what value for t would cause t minus 2 to be 0? What value of t would make t minus 5 0? Well, if t equaled 2, 2 minus 2 would be 0, so 2 seconds. And if t equaled 5, 5 minus 5 is 0, so t equals 5 seconds. So that would be your 2 seconds right there. And over here would be your 5 seconds. So that's how we can use this zero product property, and that's how we can use factoring to solve a more real world situation. All right, moving back to our presentation here. Hopefully it doesn't cut me out at the halfway through this one. So there's our solutions. Okay, solving for the variable. If we have a formula, we've got P equals 2L plus 2W. L and W represent length and width. So if you recognize this formula, this is the formula for finding the perimeter of a rectangle. And you don't need to memorize what each formula is for. You just need to do something with it. If we just had to do this problem once, and we knew what the perimeter was, 40, and we knew what the length was, 3, and we wanted to solve for the width, w, the easiest way to do it would be to substitute the information that we have, simplify that problem a little bit, subtract 6 from both sides of the equal sign, and divide by 2. So it's a fairly straightforward problem once we substitute that information in. What we're going to be asked to do is to generalize that process a little bit more and not look at it in a specific example. So you'll be asked to take that same equation, that same formula, and solve for W, but we won't be given a value for P and we won't be given a value for L. What they're looking at is that, like, if you were getting into computer programming and you were going to be asking a computer program to do the same operation over and over and over and over and over again, solving it each time for W, plug that information in and solve it for W every single time, it is an excess amount of work. And so if you're going to be doing the same thing multiple times, if you're going to be solving for W hundreds of times with hundreds of different examples, there's a better way. And so what we're trying to do is get W by itself so we don't have to solve it every time. So I'll show you what I mean. We're going to do the same operations. To get W by itself here, once we substituted those numbers in, we subtracted 6 from both sides of the equal sign. We do the same thing here. We want to get W by itself. So we're going to subtract this 2 times L. Whatever 2 times L is, we're going to subtract it away. So we're going to subtract 2L from both sides, just like we subtracted 6 from both sides here. We just don't know what L is. We also don't know what P is. So P minus 2L, they're different and we don't know what they are. So we're just kind of left with P minus 2L equals 2W. Now back over here on the left side, to get W by itself, to isolate that variable, we divided both sides by 2. We're going to do the same thing here. We're going to divide both sides by 2 to get W by itself. But again, we can't really do much with that divided by 2. We don't know what the perimeter is, so we can't do P divided by 2. We could maybe work with this 2L divided by 2, but we're really kind of stuck with what we have. So the solution is just this. P minus 2L over 2 equals W. And that's it. We're kind of stuck with that as it is. And it seems like a ridiculous thing because we're just shifting letters around and we're not really combining anything together. We're not simplifying the problem. And that can be frustrating. But the concept or the idea is that we want to be able to isolate a variable so that this formula can be used to find W over and over and over and over again. Here's another example. So I'm going to ask you to try this one. So I'm going to ask you to pause it and try it on your own. I want you to get C all by itself. This is the formula for Fahrenheit and Celsius, converting Fahrenheit to Celsius. So if you knew Celsius and you wanted to find out what that was in Fahrenheit, you could use this formula. What I'm asking you to do, what the text is going to ask you to do, is if you know Fahrenheit, solve for Celsius. So get Celsius by itself in terms of Fahrenheit. I'm assuming you paused it. I'm assuming you tried it on your own. If you didn't, please do try it on your own first. It's different on your own than it is watching me do it. I have 2 different versions of the solution here. Both of these say the exact same thing. Neither one is more correct than the other. And in a follow-up video, I will show where those 2 solutions came from. But if you didn't get either of those answers, if you didn't get either of those forms of that solution, watch the follow-up video and see how to rearrange that formula to get C all by itself. Last little bit here, identity and contradiction. So if you solve this equation, which I can do in a follow-up video, you're going to distribute through the parentheses, combine like terms, get variables into one side. What you're going to end up with is something like this. 22 equals 10, which seems odd. That should be a red flag when you do that, because 22 doesn't equal 10. That's wrong, and that's exactly right. This is wrong. This is an issue. 22 doesn't equal 10. What that means is that our original assumption is wrong. The assumption was that this equation here is true, that 6 parentheses x plus 7 equals 2x plus 10. We're assuming that this is a correct statement and that there is a solution for x that will make this true. The problem is that this original statement was wrong. This is a contradiction. There is no solution. Doesn't matter what value you put in for x here, you will never make this work. There is no way to make the left side of this equation equal the right side of the equation because the original statement is wrong. The left side does not equal the right side, no matter what value you put in for x. And we call that a contradiction. There's no solutions to that equation. So when you're solving these, if you get 22 equals 10 or 5 equals 7 or something that can't happen, there's no solution. It's a contradiction. Similarly, if you solve this one, if you distribute through the parentheses, you combine like terms, you solve for x, I get that 3 equals 3. You might get something slightly different. You might get 0 equals 0 or x equals x, but something equals itself, which is true. 3 does equal 3. 3 always equals 3. So no matter what value you put in for x here, this is always going to be true because 3 always equals 3. We call that the identity. If you get something like 3 equals 3 or 0 equals 0 or 7 equals 7, that's called the identity. And there's an infinite number of solutions. It doesn't matter what you put in for x here, this will always work because we built it up from 3 equals 3, which is always true. And then it just got more complicated from there. So you could put pi in for x, you could put the square root of 10 in for x, it doesn't matter. This will still be true, it will still work. And I'm going to stop it here. That's section 2.1.